And we're back.
Oh yeah, another episode of The Road to Code.
My name is Victor. I am one of the co-hosts for the Road to Code podcast.
And I'm John, the other co-host.
And I am Gerard.
Excellent. Jonathan.
Yeah.
Want to talk about our Patreon account?
Oh yeah. We have a Patreon. Let me share my screen. Right here. We have a Patreon where you can become a member, and our memberships include the $5 tier, which you get a free Road to Code coffee mug and early notification of our YouTube videos once we post them, and also a yearly postcard expressing our appreciation. And then for the next tier is $8 per month, and you get the same as all the perks as tier 1, and also get to join us as a guest host every quarter. And then the last one, the VIPs, the $10 a month, get access to, or early access to, our episodes before we even post them, and our raw footage of the episodes, and also get to join us for, to become a co-host every quarter.
Yeah. That the raw footage is actually pretty funny. I have to take out a lot of it just for the sake of time. But yeah, I kind of hate the fact that we take out the funny moments. But it is kind of funny to see some of the interaction between us. So cool. Thank you so much for that, Jonathan.
Yeah.
So Gerard, going to be talking about Linux again here.
Yep.
What are we talking about in this episode?
We're going to be talking about and explaining standard input and output, also known as standard I/O, and demoing the power of redirecting.
Very nice. Yeah, I'm kind of excited about this episode. Cool. Well, let's get started.
Okay.
Want to go ahead and share your screen and bring up the Linux box that you have?
Yes.
Let's talk a little bit about what standard input and output in its most basic form. Okay. So throughout time, as computers evolved, there had to be some input and there had to be some output, right? So in every case, you always had some type of input. There was a time where you would have a deck of cards that actually had commands on there, and you would run them through the machine in a certain order, and they would have some kind of result, some kind of output. And that output can vary. I mean, it can vary from outputting to a printer and just shredding down the forest to some other type of, maybe a light turning on or a series of lights turning on, right? In modern computing, and in particular with Linux, the terminal happens to be the whole input and output of every command, right? So you take a simple command such as let's take date, for example, right? If you just type in date, just with date, there isn't any really input other than the fact that we're calling the date command. So there's a command out there, right? And it's saying, hey, here's what we want you to do. But you can pass in arguments, right? And the arguments aren't necessarily, like, say, for example, you type in date space 2019, right? And it doesn't necessarily mean that 2019, I'm sorry, calendar. I meant to say calendar. Oh, yeah. Calendar 2019 doesn't necessarily mean that the input that we're sending into calendar is 2019. That's considered an argument or a parameter that we're passing in. We're just saying, hey, if you type in cal, just CAL, you're going to get the current year, right? This is, the the current month, I should say. Yeah, it's the current month. But then you can pass in an argument and say, I want you to give me for a particular year, or you can say a particular month and year. So you can say Cal 12, and it'll give you 12. Oh, this is 2012. Type in Cal 12 space 2019. This will give you December 2019. So these are arguments. These aren't necessarily, standard input values. It's a little different. So, and I kind of wanted to clear the space on, when you're redirecting input versus passing in parameters or arguments, right? So when I say, and it's interchangeable when you say arguments versus parameters, it's basically the same thing. But let's take a command like, say, for example, cat, right? First of all, let's see what type of files you have in this particular folder. Let's check to see what type of files you have in your documents. Okay, so there's a Jonathan text in there. If we want to see the contents of it, right, what we could do is we could just type in cat space documents / Jonathan.txt. There's nothing in there. Let's go check. Let's check the results of, well, Playground. Playground might have something. Go ahead and let's do a listing on Playground.
Oh, yeah.
I think these are going to be all empty files.
Yeah.
Let's see. Well, I'll tell you what. Let's go ahead and open up your File Explorer. Perfect. So leave that open. Let's go back to your terminal. And let's just type in, let's go ahead and create a text file. And you'll see that notes appeared in the file over on the left-hand side. Let's edit notes.txt. We can do this with Nano. And let's go ahead and type in a few things. Let's go ahead and type in, I don't know, Mary had a little lamb. We're testing your typing skills here, Beej.
Oh.
Jack and Jill went up the hill. Jack be nimble, Jack be quick. Cool. And then do a Control O to save it. Nice. So essentially what we would do is we wanted to, if we want to see the contents of this file, we can easily use the cat command and say cat space notes.txt. And it'll give us the content of the file itself. But with input and output, and again, this is not, we're not saying, hey, the cat command, we're not saying go take this as standard input. What we're saying is this is an actual parameter. So we're passing in the file name as a parameter, right? In order to identify, the standard input of the terminal, it's a better demonstration if we just type in cat without any parameters. And so you'll see that it just kind of sits there and does nothing, right? So now let's go ahead and type in hello and press enter. And it spits it right back out. So the cat command is a perfect example of standard input being the terminal and standard output also being the terminal. Does that make sense?
Yeah.
So the standard input is a terminal. In other words, you type in a couple of things with your keyboard and it sends it through the cat command. And then the standard output is the terminal. So it just spits it right back out, right? So let's do a Control C to go ahead and cut this. Now, let's say we want to redirect our standard output, right? Let's go ahead and type in cat. And then what we need to do is we need to identify that we want to redirect our standard output. So we would do that with a 1 because 1 represents standard output. And then we would do a greater than sign. And then we're going to go ahead and we'll give it a name of a file. We'll just say something like notes2.txt. All right, go ahead and press enter and we'll see what happens. So we get the same results. I mean, it's still waiting for us to do something, right? So let's go ahead and type in hello, goodbye, see you next time. And press enter and then Control C. And let's go see what's in that notes too. We can use the cat command just to go and see that.
Whoa.
What?
So essentially, I love to use this cat command as an example to show redirection, right? In the first example, we typed in cat without any parameters, and whatever we typed in the terminal, it just came right back out to the terminal. In our second example, we typed in hello, goodbye, see you next time, and it didn't send it right back out. It actually sent it over to the text file. So that's how we redirect it, right? Now, I think it's important to understand that even though each one of these has a name, right? We have standard input, standard output, and then we also have one called standard error. And so standard error happens to be, well, let's start with standard input. Standard input is 0. Standard output is 1. Standard error is 2. And you'll notice that when we did the cat 1 greater than sign, and then we redirected to notes 2, that's the default. We can easily leave out the 1. So if you type in cat space greater than, and then notes 3, let's go ahead and do notes 3 dot text. Yeah. And let's do the same thing. Hello, goodbye, see you next time. And then let's go ahead and check. We'll see what's in notes 3. So we didn't include the 1. That just happens to be the default, output. So you can actually leave out that number. I mean, if you want to make it readable and specify like this is going to standard output, then you include the 1, but by default, it automatically does it. So we already know that 1 or 0 is standard input, 2 is standard output. So how do we get standard error, right? So let's go and cause an error. Let's go do something like date space -k, which doesn't exist. Let's just go ahead and put it in there. That's an error, right? It says, hey, your date option, invalid option, K. Try date -- help for more information. But if we want to redirect this to a file, let's go ahead and do up arrow, and then we'll do a greater than, a space greater than. Sorry, you need to put a 2 before the greater than. And then let's go ahead and redirect it to errors.txt. So it didn't give us any message on the terminal, and that's because we redirected standard error to the errors.txt. So let's go look at the contents of that errors.txt. Kind of cool, kind of cool. Same error as we got earlier, except this time it went to a particular file. So using the single greater than the single greater than puts us in an override mode, right? Let's go and do the cat greater than sign to the file notes2.txt. And then just type in some gibberish in there. And let's look at the contents of that. You'll notice that we lost the hello, the goodbye, and the see you next time, right?
Yeah.
That's because the single greater than sign puts us in an override mode. So it's always overriding the file. But
Mhm.
let's say you want to append, right? In order to append, you have to use two greater than signs. So if we just up arrow and then add a second greater than sign, and then just start typing some other gibberish, or maybe, after the gibberish, we can even type the hello, goodbye, and see you next time. And Control C, and let's look at the content of that notes too. So not only did we keep our original line that was entered the first time, it added, so it appends it. Kind of cool stuff, huh?
Yes. I like it.
So now, one of the things that I want to demonstrate is we already know that with cat, we can pass it a parameter and say, go give us the contents of notes 2, right? But what I want to do is I actually want to change the standard input. All right. And the way that we do that is instead of passing notes2.text as a parameter, we're going to override standard input and send in the file through standard input. And the way you do that is you would type in cat space less than. And even with the less than sign, we can actually prepend the 0 to the less than sign to be very specific. So if you put a 0 before the less than sign, and then if you give it a space and then type in notes 2, we'll go ahead and press enter. You see that it actually read it. We used to pass it in as a parameter, but now what we did is we said override our standard input and take the contents of note 2 and type it into the cat command. We can also go as far as, since the less than sign is a default to input, we can actually remove the 0. So if you just up arrow and remove the 0 and press enter, yep, it's the same thing, essentially. So now we're going to do a combination of standard input, overriding or redirecting standard input, and redirecting standard output. So if you just up arrow, and what we're going to do is we're going to redirect the standard output to another file. So I'll go ahead and do the greater than sign. And let's use a file called notes4.txt. So essentially, we've taken the standard input and redirected through notes 2. We said, hey, take notes 2, send that to the standard input. And then cat, when you do the standard output, you're going to output it to notes 4. So we just do a cat's note 4. You can see where we've written the contents of one file to another file. So these are, I mean, in its basic form, right? I think this is a good way to understand standard input, standard output, and standard error.
Yeah.
Where I think people get confused on like what it is, how it works. But just keep in mind that every program has an input and every program has an output. Even if the output is nothing, it's still considered an output.
Mhm.
This, Jonathan, this relates very closely to a lot of the functionality that we do in our programming, right?
Yeah.
Yeah. So, Jonathan, would you mind sharing your screen just for a moment? And let's open up the significant project. So each one of these methods is like a little program, because when we call the create account from Postman, we're passing in a model, right? We're saying, hey, here's a username and password, but we're passing in a like a JSON format. And that JSON format gets translated in the parameters, which happens to be from the body, and it's going to be a type of register model. And then it gives us a parameter name of model. So that's our arguments or our parameters coming into our method. And then we run through the logic. And then on line 20, we say return OK and return the model.
Mhm.
And that's our output. So every program, even from the command line, it started with the command line, but now even with our programs, we have an input and we have an output, except that the IO or the input and the output are different. In this case, we're receiving it through a web API, and then we're outputting to the response of that web API. So that happens to be the standard input and the standard output for this particular method. Does that make sense?
Yeah.
Very cool. Let's show the power of redirecting. There's a command that is very powerful, and it's called find. Good. PJ, go ahead and share your screen again. Let's go ahead and clear the screen. Whoa, was that a hotkey?
Control L.
Control L.
Oh, I thought you just did it with your mind.
That's right. Control L. Did you ever figure out the hotkey to shut down the window?
No.
No. I want to say
Control Shift Q.
Control Shift Q,
Yeah.
and then Control T is the hotkey to open it.
Yep.
Cool. Is it possible for you to hold down the control key and then mouse up to increase the font size in this window?
No.
No, it doesn't. Okay. Oh. What about that little menu?
Oh, here we
Oh,
go.
there you go. Oh, nice.
Whoa.
Nice.
Nice. I like it.
Picasso. I like it. There you go. That big enough?
Yeah, that's cool.
Or bigger?
I think that'll make it a lot readable for the kids at home. There's a command called find. Let's go ahead and just type in find. Let's see what it does.
Holy.
It's just going to find everything, right? So, yeah, no, we don't want this. Let's type in find space period. And so the period basically just means this current folder. Okay. And we want to only, you see how I came up with all these text files? What we want to do is just list folders or directories. And the way you do that is you type in -type D or -type space D, I should say.
Type? Like
Type. Yep.
Space D.
Yeah. And then go ahead and press enter and see what that does. So you'll notice that none of the text files came up.
Yeah.
But it's actually like recursive, right? It goes through every single folder
Yeah.
as it finds it. Let's put a limit. Let's say go ahead and up arrow and replace that type D with depth space 1. Oh,
Is it max depth?
try max depth.
Am I spelling depth right?
Yep. Yeah.
Oh, there you go.
Look at that. And you only get the first level of the folders. You can do max depth 2, max depth 3, so on and so forth, right?
Oh, yeah.
So that's a pretty powerful command, right? What I like about this find command is that you can go and find stuff and then you can execute a command towards it, against it.
Huh.
So I think what I want to do is Let's go. I wonder, let's give this a test. Go ahead and open up a Firefox. If not, we'll have Jonathan do it. That tech command is so much faster, huh? Let's go to a website called GitHub, GITHUB.com. And let's see if you can do a search. What's your handle, Jonathan?
iJack213.
iJack213. See if you could find iJack213.
Users 1.
Where you see that?
Scroll down, all the way down.
Oh, there you go. Nice. Go ahead and follow. I mean, go ahead and click on his name. And let's go look at his repositories.
Repositories.
My repositories.
Your repositories. Okay. Let's open up each one of these in a different tab. You see where it says code, the little green button?
Yes.
Go ahead and click on that. And then copy that link. You can just do that with that. And let's go over to the terminal. And you're at your home folder.
I believe so.
Let's go ahead and create a folder called repos, REPOS.
Okay.
McDar.
McDar.
It's kind of funny that you can't forget that command, huh? And then go ahead and change directories into that folder. Hey, Gerard's getting pretty good at this terminal thing, huh?
Yep.
So the command that we're going to use in order to bring all those files from each one of those repositories is called git. So it's GIT space clone.
We have to install Git.
Oh, I didn't realize we got an error. My standard error input output failed to see that. Yeah, let's do a sudo apt-get. Gerard, you're like a hacker now, man. All right, up arrow a couple times and let's see if it works. Excellent. Let's go do that for the other tabs. Let's go copy the URL for the other ones. Sweet.
There we go.
Let's do LL and see what we make sure we have those folders in there. I'm just gonna press enter at that point. Nice. Very cool. All right. So let's assume that we want to go and check the status of each one of these folders, right? Normally, you have to go and change directories into each one of these and then run a command. So let's go ahead and do a change directory into creating a survey. And let's type in a git space status. So you're on the main branch. The branch is up to date, nothing to commit, working on a clean tree, right? And imagine you have to do that for every single one of those. 4 of them isn't that bad. But imagine you had like 20, 30, 50, 100 of these repos on your machine, right? Because you're like a hacker and you're just taking everybody's code and making something of it. Or just, you may be studying and learning from other people's code, right? And you just want to go and check the status or maybe get the latest on each one of these. That would be a painful process to go into each folder and check the status of each one, right? Let's go ahead and go back up to the parent directory. And let's go ahead and use the find command. And just like we did find, period, yep, all that good thing. What we want to do is we want to actually execute a command on each one of these folders. So first of all, let's go and find all the folders, right? So let's go find period and then do a dash max depth of 1 to make sure that we're just seeing the folders themselves. So that gives us each folder, right? And it's just listing the first level.
Yeah.
And it's only listing the folders themselves. The what we want to do is we want to use the exec command. So exec happens to be a parameter that the max or the find receives, and then we can go ahead and execute. So I'll go ahead and up arrow, and let's go ahead and do the dash exec. And on that dash exec, we want to go ahead and specify the command get. The problem with executing the get status here is that it's going to execute it against the current folder. We want it to execute against the folder that is being specified for each one of these lines, right?
Yeah.
So we can use the dash dash get dash dir, and then that would be equal to the just empty curly braces. And that empty curly braces just basically says, for every line that find is returning, that's going to be the directory that I want you to execute the command of get, right?
Yeah.
And then the next one, what we want to do is we don't want to go and set it to that directory, but there's a special folder that Git has. It's a blind folder. In other words, it's hidden. You can't see it. It's called .git. So you do /.git, and it'll specify that you want to execute it against that particular folder. And then we're going to add another argument to the git command, and we're going to say -- work tree. And that's going to be equal to the present working directory. So we'll do the $PWD all uppercase. And then we'll do /, and then we'll also give it the curly braces to specify whatever folder is being specified. That's the placement of that work tree. And then finally, we run the status command.
Bam.
There you go.
Oh.
So essentially, this would run the find in the current folder and go and check all the folders in the first level, and then run the command exec git, and then specify in the git command, specify that the folder happens to be the folder that's being passed in, redirected from standard input. And we're specifying that it'll be the .git folder. And then we're going to set the working tree to the present working directory, and then the folder that we're passing in. And then what we want to do is we just want to pull in, check the status. But along with that, if you just simply up arrow and replace status with pull, go ahead and press enter, this will go and check the status of every one of the repos and grab the latest code. Can you do an LL in there? Go ahead and share your screen, Gerard, and Jonathan. And let's go over to your GitHub. And let's go change, let's go change Guntox, since Guntox happens to be one that's in there. And let's go to the README file. Go and click on the README file. And you see the little pencil up on the, go ahead and add something. This is there you go. And save this. At the bottom, it'll say save. Commit your changes. And so here we have a change that Jonathan has done to the repo. Gerard, go ahead and share your screen again. And we don't know, you may not even know what repo he's updated, but you just want all his updates. So simply update, up arrow, and replace the status with pull. We're going to pull all his changes and press enter on that. Look at that. It went to go and grab that one file that changed. So if we go ahead and change directories into Guntox. And let's do a cat on the README file. Kind of cool, huh? I mean, this is the power of redirection, where we can redirect the input from one command to the other. In this case, we're taking the standard output from the find command and we're sending it in as standard input to the get command using the -exec. This is a very advanced example, obviously, but it just goes to show the power of redirection.
Craziness.
All right. Yeah, I think this is a good place to pause and kind of ponder on this. What's in store for the next episode, Gerard?
The next episode, we got advanced features of the standard IO
mean, this wasn't standard. This wasn't advanced enough. Do you want more?
Yep. We'll be talking about piping, teeing, and XArgs.
Very nice. Very nice. Oh, man. So if people are enjoying this content and it's helpful to them, how can they show us appreciation, Gerard?
You guys can head on over to buymeacupofcoffee.com/theroadtocode and buy us 3 coffees.
That's right.
Or one of each.
That'd be kind of nice. Yeah. So very cool. Well, until next time.
Peace out.
Peace.
Bye.